So the goal of this iPhone charger project was to develop a device and that would be capable of powering an iPhone, charging it, using energy supplied by a renewable source. When I was thinking of ideas for this, I looked at solar and mechanical ideas, and I stuck with a rotational input from a motor. So you rotate this and the output is regulated 5 volts. So now I'll show you the internals. What we got here is the enclosure. It's a tube. These lids keep the circuit from falling out. These screws hold the motor in place. So I'll just show you. Yeah, it fell down. So this is the motor. Salvaged from a microwave. It's an AC motor. It runs on 120 volts, 50, 60 hertz. So this is sort of the average, rotational speed you get. And so the output is, it's a sinusoid. Sinusoidal output about ranges from 30 to 70 volts. That's what I got when I tested it. So in order to get the iPhone requires a 5 volt input for charging. And obviously, it can't be directly plugged into the motor. So all the circuitry goes through. First, this transformer will step the 30 to 70 volt AC from the motor down to about a peak of 15 volts average, that's what I got. And then it goes through these diodes from a diode bridge for rectifying the AC to DC. Again, with the peak being on average 15 volts. There's this storage capacitor. It's electrolytic. Can't really see value. This is 100 microfarads, 16 volts. So this is for storing storing what we get from the output of the rectified DC output. Stores it, and the rectified DC output also goes into its powering the control circuitry, which consists of an op-amp, an LM741 op-amp, and a 555 timer, TLC 555. So the LM741 provides linear feedback to the 555. So the LM, this battery here, this is a coin cell. It's not actually being used at all to power anything. It's simply providing a reference voltage for the op-amp so that it can compare the voltage measured across the capacitor, so the DC voltage that we're getting, to this reference voltage. And then if that is greater than this reference voltage, then the op-amp sends a feedback signal. It's a continuous linear signal to the control pin of the 555, and that causes the 555 to adjust its the duty cycle of the PWM output. Very little current is being drawn by the op-amp from this coin cell. So I expect this will last a very, very long time. It's not being used to power anything at all, so all it is a reference voltage. Right. So next we have the 555, which has several resistors and a capacitor for timing. When the op-amp detects that the capacitor voltage is above the reference, the duty cycle of the PWM output of the 555 will increase. The output is fed into the base of the transistor so that the capacitor will discharge through a USB here. This was taken from a USB port from discarded computer parts. The capacitor will discharge through the USB receptacle, and then that goes through the iPhone. So it provides a regulated 5 volt output. So when the capacitor voltage gets above 5 volts, it will will tend to discharge more. When it reaches 5 volts, it'll be prompted to discharge so that it maintains 5 volts. And if it's below 5 volts, it will, instead of discharging, the duty cycle will decrease, and it will wait for the capacitor. The circuit will wait for the capacitor to charge up to the 5 volts. That produces the post 5 volt output. My last measurements put it at about 500 milliwatts, though very approximate. But that's about the power supplied by an iPhone, the traditional iPhone charger. So now I'm gonna show it working. I'll just put everything back together first. Alright, so I put it back together, and now I'm just gonna demonstrate, using it to charge an iPhone. You'll see that the iPhone will, charge on and off. Well, because when you turn it, it's not consistent, so it's going to buzz and indicate that it's charging, and then it's going to stop. If this were connected to something like a, some sort of hand crank system or a bike or something, then you could get it to charge consistently. So yeah. So right now I have it. You can see it's not connected very well. I have the USB receptacle, and the USB charger is in the receptacle, and then the output of the charger is connected to the USB ground and power. Hold on. And there you have it.
Damn, that's cool.